Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from May June 2022, paper 2, variant 2. In this lesson, we will talk about conservation of momentum, Young's double slit experiment, and some very important points about waves by solving past paper questions. Let's study together. Let's improve together. For our question number 4, part A, we need to state the principle of conservation of momentum. Imagine that we have two balls. In order to understand principle of conservation of momentum, imagine that we have two balls. We have one ball A and another ball B. Let's say speed of this ball A is UA and this is moving to the right, and the speed of ball B is UB and this is also moving to the right. In this case, we are assuming that speed of UA is greater than UB. If UA is greater than UB, so at one point, means after a certain period of time, these two balls, they will collide with each other. One is moving like this, other is faster, so they will collide with each other. So when these two balls, they will collide with each other, they will exert internal forces on each other. So we can say this is ball A and this is ball B. So here these two balls collide with each other. So there will be force on ball A. This will be to the left. So we can say this is force on ball A. And there will be force on ball B. These two forces, they will be equal in magnitude. But you need to understand these two forces, these are internal forces. These are internal forces. These are internal forces because in this case we are assuming our system, and this is our system, and our system consists of only these two balls. If there is no net external force acting on our system, momentum of system before collision is always equal to momentum of system after collision. If there is no net external force acting on this system. Net external force means that there is no friction, there is no air resistance, or there is no force by any other external agent. Then momentum of the system always remains constant. Then after this collision, we will see this is ball A. This will be continue moving this way, or this will bounce back. That is a different situation, but we are simply assuming they will continue moving in the same direction. So this is ball B. Then this ball B will have speed VB. It will go this way. So the momentum before collision, we can say P before in this case, will be equal to P after. P after. So we can write down in this case P before means the sum of momentum before collision will be equal to sum of momentum after collision. If no net external force acting on the system, and this is principle of conservation of momentum. If no net external force acting on the system. So this is how we can define principle of conservation of momentum. Let me show you how you can write down a proper answer. So this is how you can write down the answer. In your answer, if you have mentioned total momentum before is equal to total momentum after, you will get 1 mark, and this is M mark, mean it has to be in your answer. And the second mark is A mark if you have mentioned no external force acts on the system. You will get A mark. So this is how these 2 marks will be awarded. First mark is M mark. It must be in your answer. If you haven't written this one, you will get no mark. And also it doesn't make any sense. If you simply say no net external force, that is not principle of conservation of momentum. So the first mark is M mark and the second mark is A mark, mean answer mark. For part B, it is given to us two balls X and Y move along horizontal frictionless surface as shown from above in figure 4.1. As you can see in this figure, we have ball X and the mass of ball X is 3 kgs and velocity of ball X is 4 meters per second in a direction at an angle theta to the line AB. And ball Y has a mass of 2.5 kgs and a velocity of 4.8 meters per second in direction at an angle theta to the line AB. The balls collide and stick stick together. After colliding, the balls have a velocity of 3.7 meters per second along the line on the horizontal surface, as shown in figure 4.2. For part B1, we need to consider components of the momenta along the line AB, and we need to calculate value of theta. So very important point. So this is the hint is given. You have to consider components of momenta along the line AB. So this is hint, and also you have to follow this hint to answer this question. And it will make your life easier. This is the way how you can answer this question in a simpler way. Let's try to understand how we can answer this one. We need to consider component of momenta along the line AB. First of all, let's try to understand how we can use conservation of momentum in two dimensions. It simply means that in 2D. In order to use principle of conservation of momentum in two dimensions, we need to follow the same rules as we do in projectile motion. It means we will treat horizontal motion separate and we treat vertical motion separate. In this case, we will treat momentum along X separate and momentum along Y separately. That's the main principle. So let me write down what I said. I simply means that momentum along X means sum of momenta along X before has to be equal to sum of momenta along X after collision. So this is the main principle. Along Y, you also need to do the same. Sum of momenta along Y before collision has to be equal to sum of momenta along Y after collision. So this is the main principle you have to follow. And this is very similar to projectile motion. So in this case, you have to treat momentum along X separately and along Y separately. So it just becomes momentum in one dimension. So let's try to understand how we can use this principle. If you look at ball X, you can see it has two components of momentum. It has one component along line AB and one component perpendicular to line AB. And this component is along line AB. We have to consider this component to calculate value of theta. In this case, theta is given, mass of X is given, and velocity of X is given. So simply we can write down momentum of X before collision. This one will be equal to mass of X times speed of X times cosine of theta. Or simply you can say UX. So I have written cosine of theta. So let me clear this cosine theta and I will be writing again. In this case, UX means that the component of velocity along AB. So we can simply say this is m mass of X times speed of U times cosine of theta. Means U is the speed of X. Now simply we need to plug in these values. Mass of X is 3 kgs and speed is 4 and cosine of theta. We can write down simply this is equal to 12 cosine of theta. So this is sum of momenta before collision. So we can write down momentum before, and this one has to be equal to sum of momenta along X after. So here is after. We will use this principle. Now we need to look at momentum of ball Y. If you look at momentum of ball Y, it also has two components. One component is vertically up and one component is along the line, and this is to the right. So we can write down momentum of ball Y. And momentum of ball Y, this will be equal to mass of ball Y times velocity of Y along X. Means this velocity along X. So we can say with respect to this angle, that will be uy cosine of theta. Means the velocity of Y. Simply means that velocity of Y. Now in this case, we can say mass of Y, that is equal to 2.5, and the velocity of Y is 4.8 cosine of theta. So this is momentum before. So simply we can write down here now. We have 12 cosine of theta plus we have 2.5 times we have 4.8 cosine of theta, and this is equal to, after collision, momentum is only along AB. So these two balls stick together. It is given to us these two balls stick together. In the question this is given. So we have to take mass of these two balls. So simply we will say in this case this will be mass of X plus mass of y times the speed after collision. So this is vxy. So we can simplify this. So this is 12 cosine of theta, and we can also multiply this one. Simply you need to put these values into your calculator and you will find the answer. So this is cosine of theta. And mx, so we have mass of x and we have mass of y, and the speed is also given, that is 3.7. Momentum is a vector quantity, so you have to take one direction as positive. So in this case we are taking to the right as positive, so that's the reason these quantities are positive. Now in this case simply we need to calculate value of cosine theta. So in this case you can take common from here, so we can say this will be 12 if I take cosine theta common. So here we will have 12 times 4.8. So here we will have cosine of theta. So this will be equal to 5.5 times 3.7. So we need to calculate angle. So the theta will be equal to cosine inverse of, we will have 5.5 times 3.7, and this one will be divided by 12 plus we will have 2.5 times 4.8. So if we simplify this one, value of theta in this case will be equal to 32 degrees. So this is how you can calculate this answer. So this is the answer for this question, and this question has 3 marks. The first mark you will get if you have written any one of them, means the momentum of x or momentum of y. If you have written along AB, you will get 1 mark, and that is the C mark. And the second mark you will get if you have written this step, so you will get second C mark. So this is second C mark. And the last mark is answer mark. If you have got the right answer, you will get this mark. Now I just want to highlight a little bit, I just want to talk about a little bit about this point. So maybe this will little bit confuse you, so let me rewrite this. So let me rewrite this again. Momentum of x along AB. So you have to take mass of x along AB, and you need to take the velocity of x along AB, and that is equal to velocity of x times cosine of theta. So these two are similar now, so maybe it is more clear now. So this is how you can answer. For the second part, by calculations of kinetic energies, we need to state and explain whether the collision of the balls is inelastic or perfectly elastic. So first thing what we need to do is we need to calculate kinetic energies. So we need to follow given instructions. So we have to calculate kinetic energy. First of all, let's try to calculate initial kinetic energy, or simply you can say kinetic energy before collision. So we will write down kinetic energy before collision. Before collision, you can simply draw this line here. So this is what is happening before, and this is what is happening after collision. Now before we have two balls x and y, and they have separate speeds. So we have to calculate kinetic energy of A, means kinetic energy of x, plus we need to calculate kinetic energy of y. If we calculate kinetic energy of x, we have to write on 1/2 mx ux squared, plus we need to calculate kinetic energy of y, so that will be muy squared. Now simply we need to plug in values. So we have 1/2, mass is given to us, speed is given to us, and for the y we have the mass, that is equal to 2.5, and the speed is equal to 4.8 squared. Now if we solve this one, our answer in this case will be equal to 53 joules. So this is kinetic energy before collision. Now we need to calculate kinetic energy after collision. So simply we will write down kinetic energy after. And after we have these two balls, they stick together and they have the same speed. So we can simply write down 1/2 mass of x plus mass of y times v squared. So we can write on 1/2 mass of x is 3 kgs and mass of y is 2.5 kgs, and the speed is 3.7 7 square. And if we solve this one, our answer will be equal to 38 joules. Now we need to decide, is it elastic collision or is it inelastic? Let's try to understand conditions for perfectly elastic collision. Perfectly elastic collision. Perfectly elastic. Perfectly elastic collision. Collision is perfectly elastic if kinetic energy before collision is equal to kinetic energy after. So we can also say sum of kinetic energies before collision if it is equal to sum of kinetic energies after collision. So we call it is perfectly elastic collision. Otherwise, this is inelastic collision. In this case, kinetic energy means the sum of kinetic energy before is not equal to sum of kinetic energies after. As in this case, sum of kinetic energy before is not equal to sum of kinetic energies after collision, so it means that this is inelastic collision. Because sum of kinetic energy before collisions is equal to 53 and this one is greater than 38, means sum of kinetic energies after collision. So it simply means that this collision is inelastic. So this is you need to state, you have to write down inelastic. And this question has 2 marks. 1 mark you will get, that is the C mark, if you have got right value of initial kinetic energy and you have also got right value of final kinetic energy. Then you will get 1 mark and that is C mark. And you will get 2nd mark, that is answer mark, if you have written this collision is inelastic. So this is how marks will be awarded for this question. For question number 5, it is given to us light from a laser is used to produce an interference pattern on a screen as shown in figure 5.1. Interference pattern means that you will see bright and dark fringes on the screen and that is called interference pattern. As you can see here at the center we have center bright fringe, then we have dark fringe, then we have bright fringe and then we have dark fringe. And this pattern is called interference pattern. For this question, separation between 2 slits is also given, that is equal to 0.44. Mean this is the distance from the center of one slit to the center of another slit. We can use letter A for slit separation. Distance between screen and slits is also given, that is equal to 1.8 and we can use letter capital D for this one. Fringe spacing. Fringe spacing we need to understand, this is the distance between 2 consecutive right fringes and we can use letter X for fringe spacing. Wavelength of incident light is also given, that is equal to 660 nanometers. For part A, it is given to us light waves from the 2 slits are coherent. We need to state what is meant by coherent. And this question has only 1 mark. First of all, let's try to understand what does it mean by coherent. So when we say 2 light waves are coherent, it means that those 2 light waves, they have constant phase difference. So we can simply write down, if 2 waves, they have constant phase difference, we call them, they are coherent. And that is only possible if waves, they have the same frequency. So we can write down same frequency. If the waves, they have same frequency, it means those waves can be coherent. Mean the phase difference can be constant. So let's try to understand what does it mean by coherent. Constant phase difference. So if you look at 2 waves, you can see this wave is red wave and this one is blue wave. If you look at any point, they have constant phase difference. You can also imagine that like this. We have these 2 waves. One has crest, one has trough. So always they are like this. Mean at any point you will see the phase difference is equal to 180 degrees. So it means that they have constant phase difference. So we can say these 2 waves, they are coherent. Now imagine that we have 2 waves like this. So if they move all the time like this, if they have the same frequency, they will be coherent. So they will have constant phase difference. Or you can imagine that we have 2 waves like this. So they have the constant phase difference all the time. So we call them coherent waves. So if you look at this figure, you can see red and blue. At any point, if you find out the phase difference is equal to 180 degrees. So these two waves, they are coherent. So coherent simply means that two waves, they have constant phase difference, means the phase difference does not change with time, and that is only possible if they have same frequency. Now let's try to write down how we can write down the answer. So for coherent, simply you can say waves are coherent if they have constant phase difference. We can say waves are coherent if they have constant phase difference. So we can say waves are coherent. So simply you need to write down, if waves, they have constant phase difference, they are coherent. So for 1 mark, if you write down this one, you will get 1 mark. Or simply you can say constant phase difference between the waves, if you want to write down in a proper way, between the waves. So that's all what you need to write down for the answer of this question. For part B, it is given to us for the two light waves superposing at capital R, means superposing at this point where they form the dark fringe. We need to calculate difference in the path, means we need to calculate path difference in nanometers from the slits. It simply means that we have two waves. One wave is coming from here and that wave reach at this point. Another wave, we can use different color and we can draw from this slit, and this wave is also reaching at this point. We need to find out the path difference, means the difference in the distance traveled by blue wave and red wave. So that difference we need to find out. We can also draw the normal line here. So this one is the normal line we can draw here. So this is the path difference. So you see, travel this much distance more than the red one, and that one we need to find out. Now first of all, we need to understand path difference between, for example, at this point we have n is equal to 0. It means that path difference is equal to 0 when the waves reach at this point O and they form the bright fringe. And if you look at point Q, at point Q n is equal to 1. It means that the path difference between two waves reaching at this point is equal to 1 lambda, and this one is equal to path difference between these two waves, PD, we can simply say, has to be equal to 1.5 times lambda, because at this point path difference is equal to 1 lambda, and at next dark fringe path difference will be equal to 1.5 lambda. So simply in this case, path difference PD is equal to 1.5 times lambda. Simply we can say wavelength. So this is 1.5 times 660 nanometers. If we multiply this one, our final answer will be 990 nanometers. So simply we need to write down here 990 nanometers. This question has only 1 mark. If our answer is right, you will get this mark. For the next part, we need to calculate phase difference. Phase difference again between two waves when they superpose at capital R. We need to calculate phase difference. So one thing we need to understand, the phase difference, dark fringe is formed. It means the phase difference is equal to 180 degrees. Let's try to understand this one in a little bit different way. We need to understand phase difference. So I will be writing here the phase difference. Simply we can understand this one with the help of formula. Phase difference divided by 360 degrees. This one has to be equal to path difference. So I can simply write down this one has to be equal to path difference divided by lambda. Now for this question, we need to calculate phase difference. So I will be writing here phase difference. So this is what we need to calculate. Phase difference in this case will be equal to path difference. So this is path difference multiplied by 360 degrees, and this one has to be divided by lambda. Now from here we can say path difference is equal to 1.5 times lambda, and this is divided by lambda and multiplied by 360 degrees. So this lambda we can cancel with this lambda. Now 360 degrees you need to multiply with 1.5. So our final answer in this case will be equal to 540 degrees. So the phase difference is 540 degrees. This formula is very important. You can see in this formula how phase difference and path difference, they are linked together. So the understanding of this formula is very important, and you will see this type of questions in many past papers. So try to understand this concept, how these two, they are linked together. So in this case, phase difference is equal to 540 degrees. So we can also understand this one in a little bit different way. For example, the phase difference here will be 0. Phase difference here will be equal to 360, and phase difference here, next dark fringe, so the phase difference will be equal to 360 degrees plus 180 degrees, and this one will be equal to 540 degrees. You can also simply calculate like this. So this is another way to calculate phase difference. So n is equal to 0, it means phase difference is equal to 0. N is equal to 1, phase difference is equal to 360 degrees. So the next one, 1.5, so next one will be 360 plus 180. So this is how you can calculate. For part C, we need to calculate the distance OQ. It simply means that we need to find the fringe spacing between the center bright fringe and the first bright fringe, means the first order bright fringe. Let's say fringe spacing is equal to x, and the slit separation is equal to a, and the distance between slits and screen, let's say that distance is equal to capital D. Now we need to understand how these quantities are linked together. So simply, this is Young's double slit experiment equation. According to Young's double slit experiment equation, AX is equal to lambda times T. In this case, we need to find out X. So we can simply write down this is equal to lambda times capital D divided by A. Lambda is given, that was equal to 660 nanometers. So we need to convert this one into meters. So you need to be careful with units. So this is value of lambda. D is given in meters, so simply we can write down this is 1.8 meters, and slit separation is given, that is 0.44 millimeters. So we have to convert this one into meters. Now simply, if we put these numbers into calculator, we can find out value of x, means we can find out fringe spacing. That one will be equal to 2.7 times 10 to minus 3 m, means 10 to minus 3 meters. So this is our final answer, and this is the fringe spacing. X is called fringe spacing. So simply you have to use formula for this question. Fringe spacing between two consecutive bright fringes. Spacing between two consecutive bright fringes. This question has 3 marks. The first mark you will get, that is C mark, if you have used this formula, if you have written this formula. And the second mark you will get if you have plug in values, mean if you have sub in values. And the third mark is the answer mark. If you have got the right answer, you will get a mark. So this is how marks will be awarded for this question. For part D, it is given to us the intensity of the light incident on the double slit is increased without changing the frequency. Describe how the appearance of the fringes after this change is different from and similar to their appearance before the change. Let's try to understand what is happening in this case. First thing you need to understand, we can say the first case. I will simply write out here case 1. In case 1, let's say we have intensity of the light is this. So this is intensity, the amplitude of the wave. So two waves, when they meet at one point, they will form bright fringe or they will form dark fringe. So first of all, we will take these two waves. So the intensity amplitude is this one. So these two waves. So when these two waves, first of all, let's say they are in phase and they meet at one point. So we can write down in phase and they meet at one point. They superpose when they are in phase. So when they will superpose at one point and they're in phase, we will see a super crest. So this is what we will see, super crest. And when they're anti-phase, they will form the dark fringe when they're antiphase. So this is in phase, so in this case you will see a bright fringe. So this is what is happening in the first case, bright fringe. That when these two waves, they are antiphase, mean one wave is this and the other one is this one, and they superpose. These two waves, they will cancel each other and we will see no light. So simply what we will see this one, and this is what we are seeing is dark fringe. So this one is dark fringe. Now the second case, when the intensity has been increased. So the first thing we need to understand, intensity is linked with amplitude of the wave, amplitude square. Now we can write down, we have two waves but the amplitude is greater than before. So let's say the amplitude is greater than before, and when these two waves, they will meet at one point, means they're in phase and they meet at one point, we will see a super crest. So I can draw here, in this case you will see a super crest. You see the intensity of the bright fringe has been increased. So simply in this case, bright fringe will be brighter than before. So we will write down bright fringe will be brighter than before because its amplitude is greater. So the bright fringe will be brighter. Now if you look at these two waves, when they meet and they cancel each other, mean they are in antiphase. So again we can draw. So we have one wave, it has higher intensity, and we have another wave, this one also has higher intensity. So we can draw this bit. Again, they have the same amplitude. And so this has positive amplitude, this has negative. So when these two waves, they will meet, they will cancel each other. So we will simply see this dark fringe. So in this case, there will be no change in dark fringe, but there will be change in bright fringe. Means the bright fringes in this case, they will be brighter, and the dark fringes, they will stay same. We will see no light. Dark fringe, no change. So we can simply say they will stay same. There will be no change. And also we need to understand, if you look at the formula, the second thing you can understand is, if you look at x, we have discussed that Ax is equal to lambda times t. So we can say x is equal to lambda times capital T divided by A. We are not changing A, so A stay constant. We are not changing D, D stay constant. Frequency is the same. It's telling us same frequency. So it means lambda is also the same. So it means X also stays same. So fringe spacing is same. In this case, we can say bright fringes, you can write down. This question has 3 marks. So first point you can write down, bright fringes get brighter. So they're brighter than before. Get brighter, or you can simply say bright fringes are brighter than before. One point you can say. And the second point you can say, no change in dark fringes. No change in dark fringes. So this can be the second point, no change in dark fringes. Again, they completely cancel each other. So no light, we don't see any light. Then the third point we can say, fringe spacing is the same. As X is same, you can say fringe spacing same. So fringe spacing same. That's all what you can write down for this question. Or you can simply say no change in fringe spacing. Or you can say fringe spacing stays same. For part E, it is given to us the light of wavelength 660 nanometer is now replaced by blue light from a laser. State and explain the change, if any, that must be made to the separation of the slits so that the fringe separation on the screen is the same as it was for light of wavelength 660 nanometers. First of all, we need to understand the wavelength of blue light. This is shorter than 660 nanometers. So in this case, it simply means that lambda has been decreased. For this question, we need to keep X same. We have to keep fringe spacing same. Means we have to keep X same and we have to keep D same. We have to change slit separation. Now, if we simply look at formula, AX is equal to lambda times D. We have to keep, in this case, X same. We have to keep, in this case, D same. So we can write down A is equal to lambda D over X. We have to keep D same. We have to keep X same. So if lambda decrease, it simply means that we have to decrease A. Now let me explain to you how you can write down answer for this question. This question has only 2 marks. For this question, you need to state and you need to explain. So first of all, what you need to state means what kind of change has to be made to the slit separation. So in this case, slit separation decreases. So the statement is that slit separation decreases. So we can write down our statement, slit separation decreases. So this is our statement. And then we need to explain this one. Means we need to write down explanation. We need to explain this one. Our explanation will be as the wavelength of the blue light is shorter than 660 nanometers, is shorter than 660 nanometers. That's reason slit separation has to decrease. So here we have statement, here we have explanation. This question has 2 marks. The first mark is M mark. If you have written this explanation, you will get 1 M mark. And the second mark is answer mark. If you have written slit separation decreases, you will get answer mark. That in this case, if you simply write down slit separation decreases, you will not get any mark because you have to get M mark to get A mark. So you have to write down, first of all, wavelength of blue light is shorter than 660 nanometers. So slit separation decreases. So this is how you can answer this question.